Hello everyone. In this video, I'm going to show you how to do an implicit differentiation. Well, what is an implicit differentiation? Basically, up to now, we have been doing explicit differentiation, which is basically the normal kind of differentiation. So for example, if I have y equal x squared, and I want to differentiate that y for x, I'm going to say dy over dx, or I can say y prime equal to x. So explicit differentiation is basically when you just have a normal y function, y equals something. So it's a function explicitly in terms of x. And you have to use for example, the chain rule or the power rule to differentiate with respect to x. Now, what about if the function is not written in a form y equal, like something else? So let's look at this here. So if I have a function like x squared plus y squared equals 16, okay, this function has not been written as y equal. Well, then you have to use something else, something called implicit differentiation. So in this case, you cannot do a normal explicit differentiation. You have to use implicit differentiation, which is basically just a special kind of chain rule. So in this case here, let's learn the most important steps to use to solve by using implicit differentiation. So the first step basically is to differentiate both sides with respect to x. So both sides of the here and here, okay, with respect to x. So for example, I'm going to have dy over dx. That's with respect to x. Or I can say, call it y prime. Okay. Now, there's something very important here. The difference between this one and the normal differentiation is that if you are differentiating a term that has y, then it's basically you need to attach a dy over dx to that term. So you multiply kind of by dy over dx. For example, say that you wanted to differentiate the term 2y squared. So if you want to differentiate 2y squared, you're going to say, okay, it's 2 down with respect to x, remember? So it's going to be 4y to the power of 2 minus 1, which is 1. And then you will multiply by dy over dx. Or you can multiply it by y prime. You can call it y prime. So why do we do this? Well, the short answer is that it's a form of the chain rule. Because there is an outside function, like this is 2y squared, of course, so that's the function. You use the power rule for the way I think about it is basically there's an inside function, and this y contains some expression. So some x expression is there. So in order to find the derivative, you have to attach dy over dx to that term. Okay, so that's the first step. So whenever you have y, you will multiply by dy over dx. Second step, you are gonna basically solve for dy over dx. What does that mean? That means you need to get dy over dx alone on one side. So your expression is going to be like dy over dx equal, okay? Okay, so let's look at this question here. I do have a function x squared y plus xy squared equals 6. Well, why I'm not using explicit differentiation? Because I don't have y equal. Okay, so you cannot. So since you have x squared y plus xy squared equals 6, you need to try to differentiate this. So let's follow the steps. So first step, we need to differentiate both sides. And whenever I have y, I will multiply by dy over dx, okay? So let's start. Here we have two functions, x squared and y. So if I call u equal x squared, then u prime will be 2x. If I call v y, then v prime will be, the derivative of y is 1 dy over dx. 1 multiply dy over dx. That's the derivative of y. It's not a constant, okay? Y is not a constant. Now, we will do u prime v plus uv prime. So, we're going to go ahead and, I'm doing this part right now. So, u prime 2x times v, which is y, plus u multiply v prime, which is dy over dx. Okay? And then the second part, which is this one here. So u is going to be equal to x, u prime equal 1. Now I'm not going to say, I could say 1 times dx over dx because we are finding the derivative with respect to x. So it's going to be 2x over dx. And of course dx over dx is 1, so we don't write it. V equal y squared, v prime equal 2y, and then remember we will attach dy over dx. So now we're going to do u prime v plus uv prime. Okay, so that's going to be here plus 1 u prime v, 1 times y squared is y squared, plus u and v prime, which is 2y dy over dx. This is the first part. What about equal 6? Equal 6 is a constant. The derivative of constant is 0. Okay? Now it's time to simplify. So, 2xy plus x squared dy over dx plus y squared plus 2xy dy over dx equals 0. So this is the first step. Now, for the second step, we need to solve for dy over dx, which means I need dy over dx on the left side. I'm going to look at the terms that has dy over dx. Well, this term has dy over dx, and this term has dy over dx. So they are going to stay on the left side. The rest will all move to the right side, okay? So let's do it. So x squared dy over dx plus 2xy dy over dx equal, when you move the other two terms to the other side, you change the sign, minus 2xy minus y squared. Now I need to solve for dy over dx. So what I'm going to do, I'm going to take dy over dx as a common factor. So what is left? X squared plus 2xy equal negative 2xy minus y squared. Now since I want dy over dx by itself, I'm going to divide both sides by x squared plus 2xy. So these will cross out each other. So dy over dx will be equal to negative 2xy minus y squared over x squared plus 2xy. Now if you can simplify it, you will simplify it. But that's basically much everything about this question. Now, there's something that I need to mention here. Basically, some people might sometimes forget to attach dy over dx. So if you forgot to do that, then basically you are not going to do it correctly. And one more thing, when you have, for example, this, some people think they treat y as a constant. So what do? They just say, oh, the derivative is 2xy. No, that's wrong. So be careful, y is not constant. That's a term, a variable that you need to factor with respect to x. Also, you might get confused because sometimes instead of dy over dx, I can use y prime. So from the beginning, I could say, I could say 2xy plus x squared y prime plus y squared plus x 2y y prime. I could do that equals 0. So instead of using dy over dx, I could use y prime. Okay? Also, yeah, let's say you end up with, you have a function like, for example, x plus y equals 7. The derivative of x with respect of x is 1. The derivative of 7 is 0. What about the derivative of y? Is dy over dx. Or you can say y plus y prime equals 0. And then you move the 1, y prime equal -1. Okay, what about this question here? Again, we are going to follow the same steps. Factor the left side and right side. Looking at the left side, x cubed, the derivative of x cubed is a 3x squared. Now, what about the derivative of the numerator over the denominator? Well, you can call u equal to x minus y. U prime will be equal, the derivative of 2x is 2. The derivative of negative y is negative. Y, you can use dy over dx. I'm going to use y prime. V equal x plus 3y. V prime equal, the derivative of x is 1. The derivative of 3y is positive 3y prime, or dy over dx. So now the derivative here will be u prime v minus uv prime over v squared. So over v squared. And in the top will be 2 minus y prime to multiply x plus 3y minus u multiply v prime. Okay, and now we can simplify. I'm going to cross multiply first, so I can take this up. So it will be 3x squared x plus 3y squared equal, and I'm going to expand the numerator. Okay, these two. So it's going to be 2x plus 6y, plus 6y, yes, minus xy prime minus 3y y prime. Now if you put the negative inside, that will be negative 2x plus y, so negative 2x plus y, and then you multiply this by the other parentheses. So it's going to be negative 2x times 1 is negative 2x. Negative 2x times 3y prime, negative 2x, 6x y prime. Then y times 1 is y, and y times 3y prime is 3y y prime plus 3y y prime. Now time to simplify. Well, 2x and 2x, negative 2x will cross out each other. Now you have 6y and you have y here. So it will be 7y. And you have negative xy prime and negative xy prime here, negative 6xy prime. It will be negative 7xy prime. And we do have 3y y prime, 3y y prime. These two will cross out each other. And that's it. So let's go back. 2x and negative 2x crossed out. negative 3y prime, positive 3y prime crossed out, 6y and y is 7y, negative xy prime, negative 6xy prime is negative 7xy prime. Remember, now we should solve for y prime. So I'm going to try to move this. So it's going to be 3x squared, x plus 3y squared, minus 7y equal negative 7xy prime. Well, I want y prime, so I'm going to divide both sides by negative 7x. So y prime, or you can call it dy over dx, equal. You can take the negative up just to turn this into positive, the denominator into positive, 7x. And here will be negative 3x squared, x plus 3y squared. And then when you take the negative up, you multiply everything by negative, plus 7y. Okay, so that's basically your derivative. Okay, what about this one? X equal secant y. Now, following the same step, we will differentiate both sides. So the derivative of x with respect of x will be 1. The derivative of secant is secant tangent, right? And then since I'm differentiating with respect to x, so I'm going to multiply by dy over dx, or you can call it y prime. Now, since I want to isolate dy over dx, I'm going to divide both sides by secant y tangent y. Same here. So what is left? Dy over dx, or you can call it y prime, 1 over secant y tangent y. Now, what do we know about 1 over secant? Well, we know secant is 1 over cosine. What about now if I want the reciprocal, which is 1 over secant? It's going to be the reciprocal of 1 over cosine, which is just cosine. So now I know that y prime will be equal to cosine y. That's this part. Now about this one here, 1 over tangent. Well, we know that 1 over tangent is the cotangent y. Here we go. Okay, now let's try to find here implicitly the first and second derivative. Well, let's try the first derivative. Okay, so now for the first derivative, I'm going to differentiate this one, and this one. So x squared is 2x. The derivative of y is 2y, y prime, dy over dx, equal the derivative of 1 is 0. Try to solve for y prime, move the 2x. So 2y, y prime equal negative 2x. And then divide both sides by 2y. So y prime will be equal negative x over y. That's the first derivative. Now what about if I want to find, which is dy over dx? What about if I want to find the second derivative, which is d squared y over dx squared? Well, we are going to differentiate this. I will call u negative x, so u prime will be negative 1. V will be equal y, so v prime will be dy over dx, which is y prime. So based on the rule, it's going to be u prime v minus v prime u, or u v prime, over v squared, which is in this case y squared. Try to simplify. Negative y plus xy prime over y squared. So now it's time to simplify. And in order to simplify, I cannot leave my answer with the y prime here. I need to replace it by the function y prime. So the function will be y double squared equal negative y plus x. And instead of y prime, I'm going to use negative x over y. And then simplify. I'm going to say y double prime equal negative y minus x squared over y, x minus x is x squared over y squared. Now I need to simplify again, so I'm going to divide this, multiply and divide by y, so I can add these two, the numerator, so it's going to be negative y squared minus x squared over y squared. Now I can take the y down, that's going to be negative y squared minus x squared over y to the power of 3. That's basically y double prime, or d2y over dx squared. Now for this question, verify that the given point, which is in this case 2 and 3, is on the curve. So if I draw a curve and I have 2 and 3 should be on the curve, not outside the curve, okay? And then find the tangent line, which is the derivative and the slope, and the normal line, the line that is perpendicular on the tangent to the curve at the given point. Okay, let's start. So in order first to find the tangent, okay, we need to find the slope, the first derivative. So we need to differentiate this. So let's try. The derivative of x squared is 2x. The derivative of xy is basically x u equal x, u prime equal 1, v equal y, v prime equal y prime. So you can say 1 times y plus x times y prime, okay? So equal 1 times y is y plus x y prime. And then the derivative of negative y squared is basically negative 2y, and then remember, don't forget to add y prime, equal the derivative of 1 is 0. Now we can isolate y prime, so I'm going to leave these here, xy prime minus 2y y prime equal, move the rest to the other side, so it's going to be negative 2x minus y. And now take y prime as a common factor, it's going to be x minus 2y, negative 2x minus y, and then divide both sides by x minus 2y. Now, in order to find the tangent, the slope, we need to substitute this by 2 and 3. So what I'm going to do here, I'm going to take y prime equal negative 2x minus y over x minus 2y, substitute x by 2, y by 3. So y prime equal negative 2 times 2 minus 3 over 2 minus 2 times 3. And if you calculate this, you are going to get 7 over 4. That's my slope of the tangent. Okay, now since we found the slope of the tangent, we can find the equation of the tangent, right? So the equation of the tangent is y equal mx plus b. So y equal m, which is 7 over 4, x plus b. Okay, now I will use again this point to find b. So I'm going to use 3 equal 7 over 4 times 2 plus b, 3 equal 7 over 2 plus b, and move 7 over 2, which is equal negative 1/2. So the equation of the tangent will be y equal 7 over 4x minus 1/2. So that's again the equation of the tangent. Now I need to find the equation of the normal. Well, we know that the normal is perpendicular on the tangent. So if I know that the slope of the tangent is 7/4, then the slope of the normal will be equal to -4/7. So the negative reciprocal. So y equal -4/7 x plus b. Again, use this point to find b. So 3 equal -4/7 times 2 plus b. So b equal 3 plus 8/7, which is equal 29/7. So now equation of the normal will be equal y equal -4/7x plus 29/7. So this is basically the equation of the normal. So let's do this question similar to the previous one. You need to find the tangent line and the normal line of this curve at the point -1 and 0. So first we need to find the derivative, which is the slope of the tangent. So I'm going to differentiate 6x squared. That's going to be 12x. Then the derivative of 3x, y. Basically, this is going to be u, and this is going to be v. So it's going to be u prime v plus u v prime. Well, u prime is the derivative of 3x, that's 3. And v is going to be y plus u, which is 3x, times y, the derivative of y, which is y prime. Okay, so that's what we are going to write here. So plus 3y plus 3x y prime, or you can call it dy over dx. And then the derivative of 2y squared is going to be plus 4y, and then multiply y prime, which is the derivative of y. And then plus 17y, the derivative of 17y is 17y prime. And finally, -6 is 0, and 0 is 0. Now we need to solve for y prime. So I'm going to take these, keep it in this side, move the rest to the other side, okay? So that's what we are going to do in here. So 3xy prime plus 4y prime plus 17y prime equal -12x minus 3y. Now take y prime as a common factor. And then divide everything by 3x plus 4y plus 17. So y prime -12x minus 3y, 3x plus 4y plus 17. So that's my slope. Now I need to substitute by -1 and 0. So we use this usually this when we substitute the function. Equal -12 times -1 minus 3 times 0, 3 times -1 plus 4 times 0 plus 17. And the answer will be 12 over 14. Okay, which is in the simplest form 6/7. Now that's the slope of the tangent. So if I have the tangent line and the normal line. Tangent line, we said that the slope is 6/7. Normal line slope will be -7/6. Now I need the equation mx plus b. Here y equal mx plus b. I can substitute y and x by -1 and 0. So it's going to be 0 equal 6/7 times -1 plus b. So b will be equal -7. I'm going to move all of this here, so it's going to be 6/7. So y will be equal 6/7x plus 6/7. So that's my first, the equation of the tangent. Now moving into the equation of the normal, y equal -7/6 times -1 plus b. I'm sorry, instead of y we will say 0. and again 0 equals 7 over 6 plus b, and b will be equal negative 7 over 6. So y equal negative 7 over 6x minus 7 over 6. So that's going to be your equation of the normal. So in this question, we need to use the implicit differentiation to find the slope of the function at the point 0 pi. Now, in order to find the slope here, we need to differentiate. So I'm going to start with this part. So if I say that u equal x squared, then u prime would be 2x. If v equal cosine squared y, then v prime would be equal to 2 cosine y. That's the first function or the outer function, and then multiply the inner function negative sine y, and don't forget to end up with dy over dx or y prime. Now if you want to just reorganize this, negative 2 cosine y sine y, y prime. So u prime v plus uv prime. So that's the first part. So we'll go ahead and write it. So x squared, my bad. So we'll start 2x cosine square y plus x squared times negative 2 cosine y sine y, y prime. So that's the first part. Now we need to tell the derivative of sine y. So the derivative of sine y will be equal to, that's a negative, sine y is cosine y, and then don't forget to multiply by y prime, equal to 0. So 2x cosine square y minus 2x squared cosine y sine y, y prime. I'm going to write y prime in different color, minus cosine y, y prime, equal to 0. Now I'm gonna take this one, move it to the other side of the equation, and take a common factor of y prime here and there. So I'll start by taking the common factor. I'm gonna do y prime negative 2x squared. I'm doing this part, okay? Negative 2x squared, okay, cosine y sine y minus cosine y, so that's as a one whole part, and then equal, I'm going to move this to the other side, negative 2 cosine x cosine square y. So that's going to be, I'm going to divide by negative 2x squared cosine y sine y minus cosine y, both sides, okay? So final answer will be y prime equal, so that's going to cross out, negative 2x cosine square y over negative 2x squared cosine x cosine y sine y minus cosine y. Now I will substitute by 0 by, so when you substitute x by 0, it will be negative 2 times 0 cosine square by over negative 2 0 squared cosine by sine by minus cosine by. When you put this in the calculator, the answer will be 0. So the slope of the function is basically y prime, which is equal to 0. So the slope is 0. That means it's going to be a horizontal line. The tangent is going to be a horizontal line. Okay, in this question, find the 2 points where the curve crosses the x-axis and show that the tangent to the curve at these points are parallel. So it's like I'm drawing a line, a curve and I have, let's say, this and this. These are x-intercepts in which the curve intersects with the x-axis. And then if you draw a tangent line here and there, kind of, you will get a parallel lines. That's what they want you to find. So let's start by finding the x-intercepts. So I'm going to take this equation, and x-intercepts are basically when y equal to 0. Okay, so I'm going to come here to the equation, substitute y by 0. So x squared plus x times 0 plus 0 squared equal to 7. So I am substituting y by 0. Now what's left? X squared equals 7. Take a square root of both sides. So x is going to be positive or negative square root of 7. So add square root of 7 and 0 and negative square root of 7 and 0. The function intersect with the x-axis. These are the x-intercepts. We're going to try to find the slope at these points and then see if they are equal, then yes, they are parallel. Okay, so we need to find the slope at these points. So now, to find the slope, we need to differentiate the function. So I'm going to differentiate this function. So it's going to be x squared is 2x. xy is the derivative of x multiply y. So derivative of x is 1, multiply y is y. And then plus x multiply the derivative of y. The derivative of y is 1, y prime. And then the derivative of 2y is y squared equal to y prime equal to 0. Again, we are doing the same. So xy prime plus 2y prime equal negative 2x minus y. Take y prime as a common factor. And then divide both sides by x plus 2y. That's the slope or the equation. Now what we are going to do, I'm going to substitute the intercepts here and see if I'm going to get the same slope. So first time I'm going to substitute by square root of 7 and 0. Second time I'm going to use negative square root of 7 and 0. So y prime equal negative 2 square root of 7 minus 0 over square root of 7 plus 2 times 0, which is equal negative 2. Now here it's going to be negative 2 times negative square root of 7 minus 0 over negative square root of 7 plus 2 times 0, and that's again going to end up also negative 2. So since the slope of the tangent of these two of the tangent line at these 2 points are equal, then the tangents are parallel. Okay, so the tangents are parallel. And why they are parallel? Because the slope is equal. In this question here, let's say that I have a curve xy plus 2x minus y equal to 0. Let's say I have a point here. And if I draw the tangent at this point, the slope of the tangent is going to be y prime. Now, the normal is going to be this point here. It's going to be this line here that is perpendicular on the tangent. Now, the question is saying if there is a line 2x plus y equal to 0, and this line is parallel to the normal. So if I know that the slope of this line is basically y equal negative 2x, so the slope is negative 2, so the slope of this line is negative 2. Since it is parallel to the normal, so the slope of the normal will be negative 2. And since the normal is perpendicular on the tangent, so the tangent slope will be negative reciprocal, 1/2. So from there we are going to start looking for the equation of the normals. So again here y equal negative 2x and the slope equal negative 2. That's going to be the same slope of the normal, and the slope of the tangent line here will be negative reciprocal. Now we need to find the derivative of the function implicitly. So that's going to be the derivative of x is 1, y plus xy prime plus 2 minus y prime equal to 0. And now we will solve for y prime. So y prime is equal to negative y minus 2 over x minus 1. Now since we know that this is going to be the slope of the tangent, so that's going to be 1/2. So now I will solve by cross multiply. So that's going to be 2 multiply negative y minus 2 equal x minus 1. Expand. I'm going to solve for x. X equal negative 2y minus 3. Now I know x. I'm going to go to this equation here, substitute x by negative 2y minus 3. So I'm going to go and say negative 2y minus 3 multiply y plus 2, again negative 2y minus 3 minus y equal to 0, and then expand. I could divide the whole equation by negative 2. That's going to be y squared plus 4y plus 3 equal to 0. So y plus 3, y plus 1 equal to 0. So y is going to be either negative 3 or negative 1. Now to find x value, we are going to take these two values, substitute it in the equation we had, which is x, remember, x equal negative 2y minus 3. So now first x will be equal to negative 2. Second one will be, the first one is going to be 3. Second one is going to be negative 1. So the points that I'm going to use here are going to be negative 3 and 3, negative 1 and 1, and negative 1. So now we need the normal. So what points we are using again? We are using 3, negative 3. That's my point. Second point, negative 1 and negative 1. Now about the slope. The slope is the slope of the normal, which was m equal negative 2. That's my slope. So y equal mx plus b. I'm going to substitute y by negative 3, m by negative 2, x by 3 to find b. So my first equation, that's my first normal. My second normal, again, negative 1 equal negative 2 times negative 1 plus b. So y will be equal negative 2x minus 3. So here are my two normals. They are parallel to this line. All of them equal a slope of negative 2.